Hello everyone, this is Dr. Fahim Mushtaq. Today we are going to discuss the asymmetric cryptographic algorithm in which we discuss the RSA algorithm. This is the lecture series of cryptography and network security. Here is the today lecture agenda in which we cover, firstly we cover the two cryptographic system, their comparison in which the symmetric key and asymmetric key. And secondly, we are going to discuss the RSA cryptographic system. Here is the introduction. Symmetric and asymmetric cryptography will exist in parallel and continue to serve the community. We actually believe that there are complement of each other. The advantage of one can compensate for the disadvantage of another. Asymmetric key cryptographic is known as public key cryptography, and whereas if we see that the symmetric key cryptography is based on shared secrecy and the asymmetric key cryptographic system are based on the personal secrecy. Asymmetric key cryptography uses two separate keys. One is private and other is the public. These keys are mathematically related but not identical. The public key can be freely distributed and is used for encryption and verifying digital signature, while the private key is kept secret and used for decryption and generating digital signature. And here is, you can see that in the figure, Alice send a message to the Bob, and at the end of Alice we say that is the sender is the Alice and Bob will be the receiver. At the sender side, Bob send a message through a public key and it move into the communication channel where the public key is locked and private key is unlocked. When the message received to the receiver end and it decrypt using the decryption algorithm in which we use the private key. The private key only known by the Bob. Here is the general idea of a asymmetric key cryptographic systems. The general idea behind the asymmetric key cryptographic algorithm, which include the key generation, in which each entity in a system generate a pair of key, a public key and a private key. These keys are generated in such a way that the private key cannot be feasible derived from the public key. Secondly, if you see that in the figure, here is the yellow color, you see that the encryption, in which to send an encrypted message to another party, the sender uses the recipient public key to encrypt the message. Once the encrypted with the public key, only the corresponding private key, which is possessed only by the intended recipient, can be decrypted the message. In other words, as previously we discussed that private key is only known by the receiver end at the decryption end, and while the public key is known to the sender end and where we have performed the encryption process. Another end here we see that is the decryption, in which the recipient uses their private key to decrypt the received message. Since the private key is kept secret, only the recipient should be able to decrypt the message. Another feature which include the key exchange. Asymmetric cryptographic also facilitates secure key exchange between the parties where have never communicated before. Protocol like Def-Hellman allow two parties to establish a shared secret key over an insecure channel without needing to exchange the key directly. In overall, asymmetric cryptographic system provide a powerful framework for secure communication, digital signature, and key exchange without requiring a pre-established trust relationship or secure initial key exchange between the parties. Nature of plain text and ciphertext in the asymmetric key crypto system. Unlike the symmetric key cryptography, plain text and ciphertext are treated as integer in asymmetric cryptographic system. Typically in the context of mathematical operation involving the modular arithmetic. That's why we say that the operation of plain text and ciphertext are represented in the integer. This representation allows for the application of mathematical algorithms such as RSA. We will discuss in this today lecture, and which relies on the mathematical property of large prime number and exponential modulo, a product of two large primes. If you see, on the other hand, if we discussed earlier in previous lecture, whereas this symmetric key, where we use the plain text and ciphertext are generally treated as sequence of bit and byte rather than the integer. Symmetric key algorithm like AES advanced encryption standard operate on blocks of data where have a different version of different bits blocks which contain 128-bit block, 192-bit block and 256-bit blocks, and apply operations such as substitution, permutation, bitwise operation to encrypt and decrypt the data. Here we will see that the mathematical formulation for the encryption and decryption, where you see that ciphertext equal to function of key into public. We use the public key in the encryption and it takes as an input is the plain text and convert into the ciphertext. Whereas on the other hand, we will see that on the other hand decryption, and we will see that the key we have using the private key and the input using in the decryption and is the ciphertext which convert into the original plain text. There are very important fact that sometimes misunderstood. The advent of asymmetric key cryptography does not eliminate the need of symmetric key cryptography. Why? This is very interesting question here we mention here, but we also have to answer that question. Symmetric key cryptography and asymmetric key cryptography serve as different purpose and have their own strengths and weaknesses. While the asymmetric key cryptography provide a solution of key distribution problem and enable secure communication between the party who have never met or exchanged key before, it tend to be computationally more extensive than the symmetric key cryptography. If we see that the symmetric key cryptography, on the other hand, it is faster and more efficient for encrypting large amount of data. It particularly well suited for the encrypting data in bulk or for encrypting data within a single entity or between the trusted party who share a secret key. So, although the symmetric key cryptography offer a solution of key exchange and addressing certain security challenges, it's often complemented by the symmetric key cryptography to achieve both security and efficiency in various cryptographic algorithms. For instance, in many secure communication protocol like transport layer security, TLS, we say that a combination of asymmetric and symmetric cryptography and are used. Asymmetric crypto system for exchange like RSA of Diffie-Hellman and symmetric cryptography of encrypting the actual data transmission like the AES algorithm. Now we are going to discuss the RSA cryptographic system. The most common public key algorithm is the RSA algorithm, name for its inventor, Revest, Shamir and Edelman. Here we take the R is from the Revest and S from the Shamir and A from the Edelman. RSA algorithm serves several crucial purposes in modern cryptography, making it indispensable in various applications. Here are some reasons why we need the RSA algorithm. Include that it provides the secure communication. RSA is widely used for generating and verify the digital signatures. Also, it's used to facilitate the secure key exchange between the party who have never communicated before. Technique like Def-Hellman key exchange, which based on similar mathematical principle as RSA, allow party to establish shared secret key over an insecure channel without needing to exchange the key directly. Also, the key feature of RSA cryptographic system is the authentication. Authentication purpose in various systems includes secure login mechanism, digital certificate. By using RSA-based digital certificate, servers can prove their identity to client, establishing the trust in online transaction and interaction. Here is also another key feature in the encryption standard, which include the it make the encryption algorithm standardized, making it inoperable across different system and platform. It is incorporated into numerous cryptographic library, protocol, software, application, ensuring its widespread operation and compatibility. Overall, we can say that the RSA play a fundamental role in modern cryptography, providing solution of key distribution. And second is we say that secure communication. Third, we say that authentication. Fourth, we discuss here is the digital signature verification. Its versatile security, widespread adoption make it essential tool for ensuring privacy and security in digital communication and transaction. Algebraic structure used in the RSA algorithm. Here is the encryption decryption ring, which include the integer plus multiplication, whereas the key generation group, which include the integer of 5 into n function and static and multiplication. RSA use the two public algebraic structure, public ring. Here you can see that the public ring in the encryption side, whereas the private ring which available on the decryption side. In RSA, the tuple e into n is the public key, whereas the integer d is the private key. RSA cryptosystem encryption decryption. Here is the basic structure that used for the RSA in the development of RSA. In the RSA algorithm was developed as a solution to the key distribution problem in cryptography. Traditionally, symmetric key cryptography requires both parties to share a secret key for secure communication, which poses the challenges of key distribution over the insecure channel. RSA introduced the concept of asymmetric key cryptography, which each entity has a pair of key and a public key of encryption and a private key for purpose of decryption. Here we see that here is alias side, where we send the message, where we send the plain text, which includes the formula for the ciphertext, which provide the plain text of encryption mod into n. Using the public key, we see that the e into n represented as e into n, and the encryption ring is used at the end of sender. We say that alias is the sender, whereas on the other end is the bob, where is the receiver end. This is the communication channel, as we discussed earlier. In this communication channel, we see that the ciphertext is moved from sender to receiver. In other way, we say that the example, a client send its public key to a server, requests some data. Server encrypt the data using the client public key and send to the encrypted data, and the client receive the data and decrypt it. Another end is the decryption side, is the where we use the private key to decrypt the ciphertext that received from the sender side and decrypt into the original plain text. Here the two key entity used for the key generation is the P and Q, and the product of P and Q is said as the N. With the example, we will see that how we can detail study the RSA algorithm. Here is the key generation algorithm. Have you see that the key generation algorithm where we see that we have selected the two large prime number which include the P and Q, and we need to generate two large number, and these prime number P into Q is implies to N, and the primes should be rough equally length, and their product should be much larger than the message we want to encrypt. Okay, keep in mind the these prime should be the roughly equal length, and their product should be much larger than the message we want to encrypt. We can generate the prime using any primality test algorithm such as the Euler-Robin test. Once we have two prime, we can compute their product P into Q, which implies to N, which is, or in other words, which equal the value which is equal to N, which will the modulus of our RSA system. Next, we need to choose the integer such as the value where the value of pi, P and the Q is less than 1, that equal to the phi of value N. The value of E will be the public key expansion. Okay, here the value of E will be the public key exponent. To compute the private key exponent D, we need to find integer D such as D steric E. We have see that equal to 1 mod into P into N. This can be done using the extended Euclidean algorithm. We have discussed earlier in our mathematical formulation chapter. Second one is the RSA encryption algorithm. For the purpose to encrypt the message M, here we mention that the term N is the message. We need to convert it to the integers from 0 and N minus 1. This can be done using the reversible encoding scheme such as ASCII or UTF-8. Once we have an integer representation of a message, we compute the ciphertext C equal to, here we say that fast exponentation P into E into N. In other words, in previous slide we see that C equal to message of encryption mod N will the formula for the encryption. This can be done efficiently using the modular exponentation algorithm such as binary exponentation. Second is the RSA decryption algorithm. To decrypt the ciphertext, we compute the plain text M as M equal to ciphertext of decryption mod N. Again, we can use the modular exponentation algorithm to do this efficiently. Here is the example. We will see that we will use a small value here that helpful to understand and illustrate how the RSA algorithm works. Suppose we choose P equal to 7 and Q equal to 11 and P into Q equal to 77. Similarly, we say that where if we get the value of 5 into N, where we have a value 7 minus 1 mean P minus 1 and Q minus 1. Here the value is less than one number and multiplication of both number, then we get the result is 60. Bob chooses to exponent E and D from Z into 60. If we have chooses E to be 13, then D then D is 13 inverse mod 60, which will be equal to 37. Note that E into D mod 60 is equal, that are inversible of each other. Now we can say that we have a public key which contains 13, that is E, and N is the 77, which is the multiplication of two prime number. We say that P into Q. And similarly, we say that we have a private key which is 37, we taken using this process. Here are the example for the encryption decryption algorithm. Now imagine that Alice want to send a plain text of 5 to a Bob. She uses the public key 13 into 77 to encrypt the message 5. Here we say that here is the message. We suppose that we have a plain text which contain a number equal to 5, and here we move to the formula. Check that formula, which is that the ciphertext equal to plain text message into encryption into mode of n. Here we see that message into n 5 power 13 mode, which will equal to 26, and we say that 26 mod 27 77, and return we get the ciphertext will be the 26. Similarly, on the receiver end, we see that the receiver end we use the private key 37 as we calculate previous slide. In the previous slide, and we will get the ciphertext which is 26, and now it's on the receiver end we will do the decryption. In the decryption algorithm, we see that ciphertext decryption of ciphertext mode of n is the formula for the decryption. Here we see that the we will see that ciphertext into n, ciphertext into D, D for the private key. We say that in the encryption algorithm or sender side we use the public key, on the receiver end we use the private key. We will calculate the value of private key which is 37, and we see that 26 power 37 equal to 5, which mod 77, which return the answer of plain text will be the 5. These are the today lecture where we discuss the why we need the symmetric, unlike the symmetric we use the asymmetric algorithm, or their comparison where we use the asymmetric algorithm, and where we use for the purpose of efficiency we use the symmetric algorithm. And meanwhile, at the end of this lecture we have see that the RSA algorithm, their key scheduling algorithm basic structure, then key scheduling, how we done the key scheduling, and then encryption decryption processes. At the end we have done the example for the RSA key management and the key generation and the encryption decryption process. Thank you for the today lecture. See you in the next lecture. Keep if you like this video, subscribe me and like this video and continue watching our channel. Thank you.